Hey, welcome to SkyTour LiveStream. It's another beautiful night in the Arizona desert. I want to welcome you guys. You know, you guys are the standby. You're the old guard here. You're the ones that are always here with me. It's good to see you guys. PG is here with us. Nice to see you, Petita. Pete Bods, what's going on? Nice to see you as well. And of course, guess who's with me? You might have well guessed it's Daryl. Hey, Daryl, how are you?
Hi, Mark. Good. You?
All right.
Hello, everybody.
Yeah, we got Donald Kunzer is with us. Vera Lucia Campos from Brasilia with us. And Marianne Robb. Strong vibes for no clouds, she says. Yeah, darn right. And so far, it looks like the weather's holding for us. So the nearest clouds are about 75 miles away. But things travel fast out there, so it could be here, on us, but maybe not. We'll wait it out and see. We're not going to waste time, though. We're going to head out and see things. Daisy and Zoe Amethyst and Lane. How are you, cousin Lane? Nice to see you. I hope that you guys all get something out of our streams. You know, we had a really, really good time the last two nights. We're going to keep on going. Rock is here, Rockstar. Amal Joshi, hey there, how you doing? And C&D boy, our Canada boy, how you doing? And Leslie Latin Taylor, welcome. It's so good to see you as well. It's so nice to be able to just stream all the time, and that's what we can do when we have this beautiful Arizona weather. All right, we're going to connect the scope over here. You can see the screen here. I've just started setting up. I took the liberty of rolling off the roof, which you can see is missing here. There's a spider web crossing in front of our camera right there. You can see the roof's off already, and it's already initialized and started up. It started up fine. And now we'll connect the scope and go through that process. Little dialog box comes up here, and we say okay to that. It's a nag screen that I can get rid of if I change what's called a driver running everything, but it works, so why fix it if it ain't broke? All right, and then we'll see the lights go on over here, indicating that we are connected to the scope of the computer. Momentarily, you'll see the lights turn orange from dark, and there they go, and the telescope is now attached and hooked up. Now I start the rest of the story. I bring up our Stellarium scope here. This is our driving system behind the planetarium program that we use to drive the scope around the sky. And I'll start up Stellarium as well. And there we go. And I know you don't see anything on the ops cam right now. That's where I'm supposed to be, and I will take care of that momentarily. And let's just get this straightened out, get everything here where it belongs. And then away we go. The moon is out tonight. It's just before first quarter. As you can see, there it is. And the planetarium scope shows us pretty much what we're seeing in the sky. So it's actually quite good.
The moon's in the teapot.
It is indeed. I was about to put the constellations up here. And you can see if I do that, you'll see that there's the teapot of Sagittarius right there. And the moon is right between these two stars in the teapot. And if we were to zoom in, and again, this is just our planetarium view, of course, but as we zoom in, you can see that the moon is here, and you can see the phase of the moon, again, just before first quarter. You know, and what's it mean, first quarter? It means it's the first quarter of the orbit around the Earth. And we talk about it in quarters. So second quarter is full moon. Third quarter is last quarter, what we call. And then, of course, we have in between those, on the way up, we have the waxing crescent, which it was just the last couple days. This is considered a waxing crescent right here as well. But we also talk about it as the several days old moon in terms of the current cycle. And then after it's at first quarter, where it looks like it's half lit, which it's always half lit, by the way, no matter where it is in the sky, it's always half lit. It's just our perspective from the Earth. We see it in 3D, so we see the curved shadows, and we see the way the shadows are. When it's past that first quarter, then we call that gibbous, where it looks like a 3/4 full moon, and then full moon, of course. That's better than saying second quarter, okay, or half moon, right? And then we have that's a waxing gibbous at that point, and then after full moon it becomes a waning gibbous, where the other side, the shadow begins to go down the other side of the moon, and the progresses to last quarter, and then finally waning crescent, and then new moon, which lasts only a few hours, and then it's back to the beginning again. Most of these phases are they're constantly changing, of course, all the time, all the phases. So it's actually really neat. The moon, I was fascinated with as a young child, and I would spare and waste no time actually getting the telescope out and looking at the moon every chance I could get, every time it was up. But then again, at that point, I didn't know anything about the sky at that point. Nothing. Okay, I just knew nothing. But then when I got my telescope and knew I was going to be an astronomer for real, that's when I began to look at the sky with a lot more interest in what everything was that I was looking at, including the stars and the odd things that some stars had near them, like globular clusters and other things. Really, really fascinating stuff. And Daryl, I think you've had a typical, same as me, interest in the night sky that always fascinated you and took you off the planet, right?
Oh yeah. I mean, even as a kid, I've told the story before when once I learned how to read and discovered the children's section in the basement of the public library, there was no stopping me. I was getting every science book I could and learning about astronomy there, and then I started looking at the sky and figuring things out.
Yep. As I did as well. And the child section was run by Mrs. Brown, and Mrs. Brown would look at me and say, "Well, Marky, what are you gonna?" Marky was what they call it. Marky, what are you gonna take out this time? And I said, "I'm looking for a good science book that has lots of math in it." Ooh, well, those are upstairs, but you can't go upstairs yet because you're just a child. That's the adult section. If you come back with your mom, well, we can do that. So I begged my mom, "Mom, you gotta come with me to the library. You gotta come with me to the library." "Why? I'm busy. But I would like you to help me check out some books." "Really?" Yeah, I gotta go in the adult section. So we went up to the adult section. Mrs. Brown kind of escorted us up there. And it was funny because Mrs. Brown was up there listening to me describe to the librarian what I wanted. I said, "I want a book on physics. How do you say this, Ma?" "I think it says physics." "Oh, okay, yeah, physics." And Mrs. Brown looked at me and said, "Are you sure, Marky?" I go, "Yeah, I am sure. That's what I want." Okay. Well, she let me take out a physics book, and I, of course, was completely lost because I didn't have any of the foundational background to understand it. But what it taught me was that this is a goal. This is where I'm going to strive. I'm going to learn this stuff. I'm going to learn this, and I am going to be good at it. That's what I basically was saying. And so I was hopeful that that would happen. And
our mom got us the Time Life Science series when we were little kids, and
wasn't that great?
I mean, we just devoured those books.
Yeah, I had a Britannica encyclopedia collection. I had a Young People's Science encyclopedia collection. I had I had Glenn Miller Orchestra on 78 RPM, which I listened to for some reason, and then I had a library. My parents actually had to build library shelves in the house, and there was 1, 2, 3, 4, 5 8-foot shelves in my house that were all my books, and it wasn't nearly enough. They were stacked on top of each other in there, and I would literally walk up to that shelf and say, okay, I arranged them because I loved how the library did it. I arranged them like the library. And I didn't make a card catalog because I didn't know how to do that, but I had a sorting system. Astronomy over here, earth science over here, geology over here, okay? and other things like that. And in space, of course. And so I devoured those just like you did. And look, this is the result. This is what you guys get for result. What you see before you, a madman who gets a crazy telescope out in the middle of the desert and sits here and laughs like a giddy little kid. Every time he sees something in the screen.
The whim of a madman.
The whim of a madman. That's right. And look who's here, Dr. Mark in Texas. How are you? It's a long time no see, my friend. Long time no see. How are you? I hope you're doing well. And I'm looking forward to hearing all about your what's going on with you. And also I see Genghis is here. Welcome to Genghis again. Good to see you. Dr. Mark, we haven't started yet. We have, but I haven't actually raised the telescope up to see anything yet. I'm still cooling the sensor on the telescope. I started the Peltier cooler on it, and you can see it's at 7.5 degrees Celsius right now. It's going to -10. But if I raise up the telescope now, you watch the telescope come up right over my head. You should be able to see some stars here in a moment. And it'll be more obvious if I change the speed exposure time from 50 milliseconds to 1 second. So I'll do that right now. 1 second. Oh, I'm glad you've been lurking. I hope you're enjoying what we do. Have you've been following everything we've been doing? I suspect. As you can see, I've recovered fully. I'd say to like 98%. Okay, so there's 1,000 millisecond exposure here, and that's the important one. You look at this guy here. This tells us this is the camera control over here. There's a telescope control over there. See the telescope right above my head, and then the camera control panel over here will float. It'll go back in as soon as I leave it. But the most important things here are the exposure time and the gain. The gain is at 350 right now. And hey there, Tara. The gain being 350, that's like ISO on a camera, the sensitivity. And so it's not a one-to-one thing. 350 is not like 350 ISO. It's actually more like several thousand ISO. But this particular camera is a dedicated astronomy camera. The pictures it takes are unparalleled. And we have a mode here. This is down here is the data. That right there is the data, and this yellow line represents how much of the data is actually being seen. And right now we got this little tiny bit that the line goes through that's being seen, this and below. But if I push this right here, then it's going to intercept that whole curve, and we'll see much more data here and many more stars. So let me do that and show you what that looks like. Okay. Now you'll notice that it looks a little rough. That's because we're still cooling the sensor right now. It's at -10 at the moment, and we have the moon out. So everything is settling out. I just opened the roof, so the telescope has to acclimate to the temperatures. And speaking of temperatures, I can go tell you what that temperature is. So I'm going to bring up our remote focusing system, which is a temperature sensitive system.
Satellite.
Yeah, is there a satellite coming through here?
I just went behind the box there for the focuser.
Oh, sorry. No, it's heading that way too, so we're not going to see it. Yeah, okay. All right.
Sorry.
That's fine, that's fine. So this is our focus system right here. Let me bring it down a little bit more. What's nice about this focus system is that we have a temperature sensor built into the telescope, because the temperature right now is 68 degrees in the dome. Okay, 67.9. Temperature's dropping overnight. It'll get lower, and in Celsius that's 20.1 Celsius, and then in Fahrenheit it is 68.1. And that means that the the focus, which is this number here, and it can be any number in there, by the way. So there's a huge range of focus events. The focus is extremely precise. We can focus the telescope very precisely and set it up so the telescope will focus depending on the temperature. All right, it'll focus to different locations, and that can go quite a number of different focal locations. I haven't done that yet. I'm still just manually focusing for now.
Last night was 50502 we found early on worked well, didn't it?
We did, and let's go back and see where we are right now, because I didn't see where we are.
That'd be a good starting place.
Oh yeah, okay, so yeah, we did that. Let's try this now. Let's see if it works tonight. Temperature's a little bit different for tonight, but here now I'll say go to. Watch the stars. Okay, it's changing. Yeah, look at it. See how the stars got smaller and more tight? So that's a good starting place. And these three numbers represented all the numbers we actually had to use last night, which is really good. Ray Bobel's here. Hi there. Hey, hey, hey. I actually talked to Ray for about an hour earlier on the phone. Nice guy, really nice guy. Ray is what I would call a super fan of SkyTour LiveStream. And so I really appreciate all the kind words he has to say, and he's done some really wonderful things. He's, you saw him donate in chat. The guy's just a wonderful human being. Thank you, Ray. So now you can see that we have a little glow here. That's actually caused by the moon, and it's a secondary glow that's caused by the moon, unfortunately. And because we are facing south, the moonlight is actually falling on the telescope just a little bit, probably on the inside edge here of this. Okay, but the moon will set, and we look here at our stellarium, and you can see where the scope is there, and the moon is not too far away. So the more we move out of the way, the less it will affect us. Okay, so now let's go here. Let me just do one other thing. I want to just do one thing here.
Says the moon will set at 10:22 Arizona time tonight.
Yeah, that was I think that's correctly. I think you have spoken wisely.
Yeah.
We also have some wind, by the way, guys. So you'll notice sometimes these are 1 second exposures that we're looking at out here with the moon right now. I'm sorry, not with the moon, but I mean with the telescope. We're taking 1 second exposures, and we know that because when we come back to the screen and we look at the camera control system, we're at 1,000 milliseconds, and there's 1,000 milliseconds in 1 second. And so every now and then, in these 1 second exposures, you can actually see it change. Like right there, it's changed. Boom, it's changed. Boom, it's changed. And it's going to go on and on and on. So we're taking these 1 second exposures, and once in a while, the wind buffets it in the middle of that exposure, and you'll see a dash. Oh, you're welcome, Ray. Hello, Tara. How are you? Nice to see you. Let's actually go check something out instead of just playing around here. We're at temperature, so we might as well go see something. Keep in mind that this telescope is at what's called f2. It's a very much wider field than it originally was when we had it in our testing observatory out here on the East Coast. I am operating this from Connecticut, so we are 2,500 miles from the telescope. So that always instills a little bit of like agita, because you want to make sure that you don't do anything that's going to cause it to break, And let me just do this, and I'm going to do this. Okay, now we're going to bring this down to here. There we go. See, I like this color. That's nice. It's better than like a a red. You know, I could do red too, but you know, I prefer the blue. You know, the blue is better. All right, so because we have a blue background, see? That's nice. So here's where the this is the field of view for our scope. It's 2 degrees, 9.9 minutes. All right, and it's by 1 degree 28 minutes, so about 1.5 degrees or so in height. So it's just over 2 degrees across and over 1.5 degrees tall. Now, what does that mean? It means that it's, if you go across this way, 2 degrees, right? The moon is 30 minutes of arc in size, and 60 minutes of arc is 1 degree. So we have 1, 2, 3, 4 moons. 4 full moons would fit right across our view here. Okay. All right. When we look at this view, we'd have 4 full moons that could fit across, and then we have 1.5. So we have 3 full moons that would go up top this way vertically. So it's a big field. So, for instance, if you say, let's go look at Jupiter, that's a problem because Jupiter is going to be small in this view. We can see it, but it's not as impressive as with a higher focal length system, which is higher magnification. And we're working on that. Okay, one way or another, we're going to have it. I also mentioned yesterday we're going to take the pier that this is sitting on, which is a fixed pier, and replace it. It's only been in operation for a few months, and we're already going to replace it with a pier that moves on its own with what's called a linear actuator. It's going to raise the whole telescope up. Okay, so we can actually get a better view of the horizon. If it's a windy night, we can bring it down. All right, and then use the building to shield us from the wind, like it's being shielded now, but still getting buffeted a little. So we'll be able to raise and lower the telescope. That's another thing. I'm also going to change. See, there's the wind right there acting on the telescope. You saw it do that. See, the front end of the telescope here has this big, long barrel on it. It's a dew shield, protects from moisture and other debris that gets in there. That catches the wind, and it moves the whole telescope ever so slightly. So on a windy night, which you can see because of that spider web that Marianne noticed, okay, in chat, that spider web gives you the idea that there's a lot going on out there windy-wise. So
there's 2 spider webs.
That's right. And here comes a satellite right there. Okay, it's a 1 second exposure, and you see the satellite coursing through. It's weird. It looks like it's a rapid tumbler. Did you see that? It was actually like a little dash. A dash is moving through. That's not a plane. Hey there, OG Skywatch. What's up? William Shatner. I don't do William Shatner. I do me. I was working on the Alien Invasion Hudson Valley documentary that's on Discovery Plus now, because I was one of the cast members with Ben Hansen and Melissa Tittle, and at one point Ben starts laughing. I go, "What are you laughing at, Ben?" And he goes, "You sound like Shatner." I went, "What?" I wasn't trying to be Shatner. He says, "No, it's the way you talk. You talk like Shatner does." I go, "Oh gosh, he's had more of an effect on me than I care to admit." Curtis, you said that's a plane. I didn't see any other lights on it though, Curtis. There were no other blinking lights on it. I mean, it looked like it could have been like I thought about it being like a belly strobe, but in 1 second, okay, you only get 1 flash per second, and this had tiny little dashes all the way along the length of it. So it couldn't have been an aircraft with conventional FAA lighting on it. You know what I mean? And by the way, Curtis, welcome back. Curtis Horn is also over on Cloudy Nights. He's one of the lead guys over there, and he's a very knowledgeable individual. So it's a welcome sight to have him here with us. Thank you, Curtis. And Greggy Gilgan is here. Well, how's it going? I'm not saying it was aliens. Okay, then it probably wasn't. I wish it was the James Webb, you know? Okay, And we're letting the scope cool down, as you can imagine. That's why I'm just sitting here waiting. But we'll give it a shot. We'll go grab something, see what we got. All right, so let's do a test, and I won't move in the direction of the moon. I'll move upwards here.
I think Donald Kunzer wants to see the all-sky cam sometime tonight.
Okay, it's up. I have it up.
If I interpret what he says correctly.
Where do you see it? Where do you see him say it?
Well, they're in chat.
Oh, he said, "Oh, can we see 360 view?" Oh, yeah. Of course, Donald. I can show you that. I will be happy to. Let me just get us into the night sky here. I know. We can look at M75, I guess. Should we do that?
Again?
Did we see M75? When did we see M75?
Well, it's a globular, obviously. I don't remember looking at M75.
Well,
maybe
again?
I just don't remember.
Well, you said again like you were bored of it.
No, I'm like, I don't remember seeing it before.
Okay.
That one in particular.
All right.
I mean, we could spend half the night looking at globular clusters just in Sagittarius.
Yeah.
You know, there's a ton of them up there.
There are. You know, they're halo objects, as we discussed yesterday, and they orbit the galaxy, as you know. Not everybody knows. That's why I repeat some of these things. All right, but we're going to check that out. And if we look at this, this is a globular cluster. It's a magnitude 9 globular cluster, which means it's not readily visible without a telescope. You need a telescope to see it. All right, so we're going to go check it out. So let's make sure the telescope is functional. We're going to do a test run, make it go to that globular cluster. So when I tell it to go, the telescope should move and move us to a star up in that region. And then that's probably the star it's going to use. Yeah, it's probably going to use this star as a high precision pointing star. The way the telescope works, guys, is it will seek out a bright star to it. It doesn't have to be a bright star to your eye. That's near the object of interest. And in this case, it's this double star. And then it's going to take it from there. It's going to then move to the object. So that makes it more of a high precision pointing. So wherever you see the star appear here, that's where the object that's going to is going to appear. It's going to make sure it's right there in the middle of the field. And there we go. It's kind of fun watching it do this. Okay, and we'll see the object. There it is, right there, right about where the star was. Look at that. And that's a globular cluster. It's not nearly as big as the one we saw the other night, which was Measure 22. But that one is too close to the moon tonight. And that one's going to be probably too overcome by the moonlight to actually see it. But there's plenty more where this came from. Were you saying something, Daryl?
I'm sorry?
Were you saying something?
One more time?
Were you saying something? I thought you said something.
If I did, I didn't realize it.
Okay, that's a no. All right, no problem. Hey, D-Man, yeah, I was looking at the rain up in up north of Prescott, and I was thinking, should I open tonight or not? And I actually was 50-50. I weighed it. I wasn't sure I wanted to do it because I didn't want to have any danger of anything untoward falling into my building out there. But I think we're clear enough. And incidentally, this is a good time to show Donald what he wanted to see. Okay, this is our all-sky cam. We can see the moon. I'm going to do a shot here that's a little bit longer than what I have. Let me change the settings here, guys. Right now, I think I'm on a 5-second shot. But I'll tell you right now, it's in milliseconds. Yeah, 5,000. So we're going to go to 12,000, which is 12 seconds. And then what we can do, we're going to save those changes, go back to our preview window, and then do a single acquisition here. and you'll see the count up there. Okay, so now it's going to start counting, and this picture will be replaced. You can just barely see the Milky Way tonight here, but that's not because it's not out there visibly. It's horizon to horizon out there with your eye. You can see that. Okay, well, here it is now. You can see the clouds this direction here and this direction here. This is to the east, and you can just barely see the Phoenix Light Dome 65 miles away. Okay, this is the south over here, and that is the east over there. So to the east we have some clouds, but they're continuing to go east, so we don't care. And the north is that's sort of northeast actually, and then the north is about here, so it's literally about here. There's Cassiopeia, and so north is right here, this right here. So we have north, south, east, and west. Those are the cardinal points for this. And Daryl wants me to flip it over. I'm trying, Daryl, I'm trying. I'll get to it. There's so much to do. Yeah.
Isn't east on the right in that image?
Yeah, that's what I said.
Oh.
Yeah, the east is toward Phoenix, 65 miles away.
Yeah.
And then west is toward these clouds, more toward the north.
Okay.
And then this is north, that's south. So.
All right. Well, that's what I thought. I must have misunderstood something.
Okay. As long as I didn't misunderstate it.
Don't mind me.
I hope I didn't misunderspeak it. So yeah, so there we go. So there's the all sky. So it looks clear. We're going to keep an eye on the weather though, guys, and make sure that nothing comes in that's going to hurt us. All right. This blue screen, by the way, is just due to the fact that we're running this this what I call it a hyper processed shot. It's actually it's called a stretch. We're really stretching the image right now, and the filter we're using passes through certain wavelengths that we want to see in astronomy, and the problem we have is that it tends toward the blue. So the background, when it's stretched like this, is going to look blue. But we always color correct those, and in our process shots, they never look this way, as you've seen. So that said, let me just go back to this and minimize it. I won't get rid of it. Okay, and then let's go back to... let's see, that globular's not very impressive right now.
Yeah.
Let's... well, that's where we belong right there. So let's... Actually, I'm gonna synchronize on that. Okay, so now our telescope and this planetarium system are synchronized together better. I also have something else in the telescope that I told you about, I think yesterday, folks, and that is I implemented what's called plate solving, so that even if we lost all of our alignment with the sky and the telescope had no idea where it was facing anymore, I could simply look at a pattern of stars like we see here, okay, and it would know the pattern and tell me exactly where the center of this image is, and then I could set my coordinates appropriately. And we've done that a number of times, actually. So that works very well. Okay, enough talk. Let's just do. Do or do not. There is no talk. There's Saturn, and it will not look impressive, especially now. There's an issue I have. Oh, well, wait a minute. We do have. Look at that. That's kind of funny. That's a Saturn nebula.
Might try that. That's a nice planetary, isn't it?
Yeah, it's a little small, but we'll try it. All right, the Saturn Nebula, we're going to try it. We're going to go there now. And you'll watch the telescope here in the building. You'll see it move. Okay. And it's going to head a little bit toward the upper part to get that star it needs to find. Okay, so it's going to grab a star. And this lags behind a little bit. There it is. It's going to that star right there. South Sud. And then it's going to center it up. I guess you'd like to see that though, huh? There it is, centering it up. And then it's going to zip away to the Saturn Nebula, which is actually deceptively bright. There it is. It's tiny, but it is interesting. And what I'll do is I'll take you just to show you what the actual process looks like. I know it looks like another star right now, and that's, again, this is a wide field telescope now. I want to put another scope that's actually got a narrow field of view, more magnified, right next to it, and thus when we go to one object, the other one goes to that same object, and so we can go between the two and see them, see the difference. I think that's a really cool opportunity for us. All right, so what we're going to do on this windy night is we're going to set our exposure to just I'll set it to 8 seconds. All right, and I'll leave the gain at that, and then I'll take off this. Yeah, see, it's gonna be too windy, but that's all right. We'll see what happens. And then we're gonna go into a live stack here. It won't, but it's gonna show you the colors better. That's what I'm gonna show you. Yeah, okay. See, the wind is just murdering us here. So I'm gonna clear the stack right now and let it do it again. It's acting like a big fan blade up there that's getting caught by the wind. Okay, there we go. So that right there is the Saturn Nebula. Let me show it to you a little better. First, let's try this.
Got that doubly ionized oxygen color to it.
Yep. That's the... Okay, this is going to probably do that. Okay, this is fine. All right, so here's, as Daryl's alluding to, this particular nebula is a planetary nebula. It's what happens when stars die. Okay, when stars die, they swell into red giants. Okay, our sun's going to do this as well. And there's a phase they go through in their late evolution where they start to do this. They start to pulsate, and the reason they do that is because stars burn or fuse hydrogen into helium. Ostensibly, that's what they do effectively. Now they're isotopes of all, not hydrogen specifically and helium specifically, but isotopes. That is, extra neutrons in the atom make it an isotope, but it's still, or in the nucleus, but it's still a hydrogen isotope or a helium isotope. Well, anyway, no worries about that. What happens is stars make hydrogen into helium, and then if they're big enough, they can make helium into carbon. Our sun may do a little of that. It's not a very big star. And then carbon into nitrogen, and then oxygen, and so on, down the line until it gets to iron. Iron is the highest periodic table element that stars can make in their cores. And when Carl Sagan said, "We are star stuff," he meant it. That's precisely what we're made of. We're made of stuff that was made in the hearts of stars at one point. Or, as it turns out, in supernova explosions. Or, as it turns out, in planetary planetary expansion, when the star runs out of hydrogen and it's fusing helium into carbon, all right, it's going to initially shrink, and then it's going to bring more hydrogen near that core as it shrinks, and then of course hydrogen fusion can begin again, and so the star bloats back up, and it keeps going up and down as more fusion products get dredged down into that core and then dredged back out of the core over time. And so the star will expand. Eventually it's going to have several shells of different material. It's going to have a hydrogen shell, a helium shell, a carbon shell. Okay, and they're outside the core of the star, all they're part of the core actually, all fusing their own elements to other elements, and that's going to cause the star to bloat really, really large. And as they wax and wane, they're going to pulsate, and as they do, the outer layers of that star kind of drift away from the star. And they can do that because the star, when it becomes a red giant, is so big that those outer layers are only very, very tenuously held by the star's gravity to the star, and then they can just drift away with the slightest of impulse. So that's what happens, and we end up seeing these shells of material around these old stars. This is what we're seeing right here. We're seeing the shell of material, and the color is because of the fact that the star's core, which is still very hot, is typically at this stage it's collapsed into a white dwarf, and the white dwarf is very hot, and it ionizes oxygen atoms that are in this particular shell of gas, and it ionizes them twice. It sends them, so it's called doubly ionized oxygen, and when those electrons that are ionized are thrown off the atom, come back into the atom, they give off light, and the oxygen light is green, right there. Hydrogen light, from what you remember, we talked about all these many times, is red. Okay, and it's not, when the electrons come back into the atom, it's not like they just go to that one spot. They go to a lot of other spots, but there's certain that win out and that are dominant. And in hydrogen's case, it's the red. We call it hydrogen alpha. In oxygen's case, it's the bluish teal color, which we call the O3 predominant transition. And so that's why these things are green like this. And again, I'm sorry with the wind we can't get a really perfect shot, but you know, it's okay. It's better than a poke in the eye with a sharp stick. So let me get out of the sky here. I don't belong in the sky. So anyway, so that's the Saturn Nebula. It's a really cool little planetary. And let's now look up in the sky.
I think that'd be a good one to visit when we get some higher focal length there.
Yeah, I think you're right. It will be a beautiful one. Okay.
There's another globular.
M2, yeah. You want to look at M2?
Sure, why not? Are you going to work your way north?
I am.
Okay.
How'd you guess? All right.
I just had this sneaky feeling.
A sneaky feeling? Okay.
Yeah.
In between forays of the telescope, I come back and I get us down to 1 second shots, because I could go far less if I want, but 1 second works for us. And then I do the hyper view here. I call it hyper processing. And then I get rid of the live stacking, because live stacking is just stacking each successive image on top of each other to help separate the signal, that is the green color and the fine details in a nebula, from the noise, which is the noise that the sensor generates on its own from trying to acquire at such high rates. All right. So
you're talking like Shatner again.
Did I?
Huh?
I did?
Yeah.
Oh boy. I didn't mean it. Okay. Alright, so let's see now. We're gonna come back here and we should be able to now, with Mesher 2 selected, we should be able to go here now. And first thing I'm going to do is I'm going to poke my telescope, because I want to get my display back here.
Thank you, Leslie.
Well, Leslie, thank you so much. Thank you very much. That's very kind. Oh my gosh, that's just incredible. Thank you. All right, so now let's go do this now. We'll get this. We're going to Mesher 2.
Second object in the catalog.
That's right. Mesher 1 is the first. It's the Crab Nebula in Taurus.
Uh-huh.
Wait until we see that, guys. That's a supernova remnant. Wow. Okay. Okay, so we're centering this star here, and that's going to be our finder star that the telescope uses to then do the little puddle jump to measure 2. And it's right there. That's the star it's on. Okay, and here we go. We come back here, and we should come back just in time to see measure 2 come in. And there it is. So we'll let the scope settle out. And there we go. And as you can see, sometimes the telescope can actually be too powerful for the object, you know. Curtis Horn asks, I'm curious what magnitude you think your setup can reach here, Mark. Well, as you know and are aware, of course, Curtis, and this is for everybody else, it depends on your night sky where you are. Theoretically, I actually know that this telescope was picking up magnitude 17 geosynchronous satellites. Without problem. I could see the trails from these geosynchronous satellites. And of course, trails are easier to see than point sources, but I was picking them up quite readily. So at least magnitude 17, and that, by the way, was here in Connecticut, because that telescope that's out there was here in Connecticut for a year, and I was doing testing on it, getting it ready for the trip out west. And now out there, I'm sure we can we could probably go over magnitude, probably mag 20 out there, I would think. And that's probably underestimating what it can do, I would imagine. But sorry about the wind, like I said. So yeah, and by the way, we can actually take this and zoom in a little bit too. We don't have to just stay here. We can pull in close, and you can see we've got some noise in here because of our wind and so forth. If I get rid of that hyper process, you'll see that that's all we got. And if I try to stack it now with the wind, it's actually it'll just be blurry, fuzzy, nasty, because this is a 1 second exposure, and we haven't had a still object in quite a bit. And actually, Tara earlier said it's quite windy in Phoenix. I saw that she wrote that. And you're welcome, Tara. I'm glad that you're able to join us tonight.
Mark, would you excuse me for a moment, please?
Absolutely.
Thank you.
Okay. Now we're going to go to auto, get the magnification correct for this next trip, and we'll take another jaunt further up north. We're going to skip the Pegasus cluster, but you know what might be nice? Might be nice to see is this guy. The Dumbbell Nebula is always pretty. Trouble is that unfortunately Dumbbell Nebula with wind, it's going to be problematic, but we'll do our best. The other thing too, it's probably going to use Albireo, by the way, which is a beautiful double star right here. At least it should use it. It does. Okay. Albireo is a nice double star, and with higher magnification, you'd be able to see this is actually 2 stars. Albireo is I think it's a K8, which is a orange star. No, not a K8. I think K3 star, which is an orange star. It's cooler than the sun, but more massive than the sun because it's actually a giant star, and it's paired with a beautiful blue B-type star. All right, what we call a late B, a B8. Okay, and so I think it's just a beautiful pairing. It's the most beautiful pair of binary stars, or true binary stars you've ever seen in your life. Okay, it's Albireo, and it forms the head of the swan in Cygnus the Swan. Okay, yeah, and as you can see, I mean, here's what I'll do. We'll try short exposures. We're gonna do 3-second exposure without our hyper processing on it. It's probably not going to come out very well because of the wind, but we'll do our best. And I got to clear this, by the way. Okay. All right, don't worry about that. That's just happens to be because we haven't done some adjustments. Yeah, you can see, unfortunately, the wind is causing us any type of time exposure is causing a problem because of the wind. That was another reason why I wasn't sure I was going to be able to open tonight, because of the wind. But I didn't want to keep you from seeing it. There it is. Look at that. Okay, this is the dumbbell. Let me just pin this here. And I'll just keep clearing the stack because we're not intending to keep these. You can see that the wind is causing some elongation. But this is another planetary nebula, another dying star, like the Saturn Nebula, that last hydrogen, gas, and possibly neon in these areas here. It's a very complicated little nebula. It is, it's almost 2 light years across, and it's really interesting because in the center there is a white dwarf that you can see on most evenings, and we can't tonight because of the wind. But this particular nebula is really interesting because if you notice, it's not just a shell. It looks like an hourglass, or as Daryl has called it, an apple core. Well, the hourglass look has to do with the fact that when this star was dying, it was already a star that was rotating pretty rapidly, probably in this direction. And so as it rotated in this direction, the gas would tend to move outward this way and not so much at the poles here and here. So that's what we're seeing here. This is the axis of the star, and it was going out that way as the star was rotating. So star death is not always the same, and that's what we're seeing here. The bulk of this material went out equatorially on this star, and that gives rise to a new kind of planetary nebula that we discovered some years ago called a bipolar nebula. This is a bipolar nebula. It shows 2 distinctive lobes, okay, like this. So a bipolar nebula is not a nebula that's misbehaving or having trouble assimilating into society. It's actually a nebula that has lobes on it that are separate and distinct. It's bipolar. So that is kind of an interesting guy because it's actually not that far from us, but it's actually hard to determine the distance to these because as they expand outward, all right, because they are expanding outward as this gas slowly leaves the star, we don't know how long it's been expanding, and we don't know if there's more gas that's outside the ionization zone for the star inside. So it could be gigantic in the sky, but we don't know the gas is there, not without doing a study, probably with a radio telescope, to examine that. And there have been some studies done, but it really is just a beautiful little planetary nebula. And they're called planetary nebulae, by the way, because of the fact that at one point they could be mistaken through a small telescope, they could be mistaken for a planet.
Yeah, I remember when I first saw M27, I thought, golly, that looks almost like a planet. The lobes of the dumbbell there, the 2 sides of the apple core, when I first saw that, I mean, it looked almost like North and South America. It looked like the ghost of a planet.
Wow. And that's interesting because when I saw it in a small telescope for the first time, I only saw the very hourglass shape. Literally, I saw this shape right here. You can see that right there, and then it comes down around like that and up. That's the only shape I saw. These fringes on the outside, that when I saw that for the first time on photos, I was like, wow, look at that. I saw it, of course, in other images from ground-based telescopes and said, I want to look for those. And, of course, I could never reproduce them with my equipment at the time. Now I can't not reproduce them. They're always there. The telescopes have really come a long way. So once again, here I am, hogging the sky again. Let me get out of there. I'll sit down here under the telescope where I belong. But isn't that cool? So that's the Dumbbell Nebula. And like I said, many of these images aren't going to be very good up on the server. But they're going up there anyway. They're going to be up there anyway. And for those that don't know, you can go to the Facebook site under my name, or the SkyTour LiveStream with Mark D'Antonio Facebook site, and there's a pinned post on each of those. And that pinned post has the link to the live server that's at the observatory. And so you can it's actually in the cloud, it's not at the observatory. It's stored off site. Every image we take, every photograph we take is all shipped up to the cloud and available to you within minutes. You get the full stacks, the full image stacks available to have fun with. You also get the pretty pictures, like that one. Okay, when we have pretty pictures to show, they're yours. In the on Facebook, I put up yesterday's pretty picture of the Sol Nebula that we took here. Again, there was no wind, and so we were able to do a long integration, that is to say, a stack of many images. And the Sol Nebula came out beautiful. I sent that to you, didn't I, Daryl?
You did. It was a beautiful picture.
Yeah, it came out really pretty. And for those that have eagle eyes, you'll notice that the stars are supposed to be round. And I'm not talking about the elongation due to the wind. Oh, Cipher 2, add it again. Thank you. That's the link to the live server, by the way, guys, right there. Thanks to Cipher. Thank you, Cipher. You know, that guy's on top of things, man. Let me tell you. So it turns out that that live server link is always there for you. Okay. And I was saying the stars are not round right now because I have what's called a collimation error. Because our F2 system is the only one of its kind in the world right now. It was made for us by Starizona in Tucson. It's called a Hyperstar. It's a product they make in Celestron. They have a whole line of them for Celestrons, but they never had one for an F8 Meade LX600 until now. And that's what we're witnessing the skies with. It's the one and only one so far. So we were kind of a prototype, if you will, for this new system. And Dean Koenig down at Starizona, who owns Starizona, runs it. Great man, very generous, very forthcoming with information, always available. And if you have any astronomy needs, man, Starizona's where to go. Okay, and they're not even paying me to make this commercial for them. Okay, I'm just honoring the time that they put in to help us. So this means that when I get out there, the Hyperstar system is a lens system, and it's in the place of the you can't see it now, but it's in place of the secondary mirror that's at the other end of the barrel. Typically, cameras are at the back end. Okay, the light comes down the tube, hits a primary mirror, goes to a secondary mirror, and then goes through a hole in the primary mirror to your telescope sensor, eyepiece, or camera. We're doing something different. The light comes down, hits the main mirror of the telescope, comes up. The mirror has been taken out, and now it goes into a lens system, and then into a camera. So the camera's at the business end. It's at the other end of the telescope, sticking out. And that means that we're going to be at a lot lower focal length. And right now we're running at what's called F2. An F2 lens in camera technology is a lens that's pretty fast. So this telescope is running very quickly, very fast. It's actually running 25 times faster than the F8 would before. So it's really something else. And that's that alignment between that thing and the main mirror is off a little bit. Now, we did have an accident out there where the telescope came down and hit the camera, and the Hyperstar actually hit the telescope early on when we had an issue. I lost connection to it. It went off and did crazy things. And the damage it caused was the alignment error that we see now. So I'll be out there in just a couple weeks, actually, because I'm teaching classes out in the desert on astronomy, and I will be going to the observatory for 3 days in the desert and spending time getting all these things fixed. Oh, and I'm probably going to get a different filter to try a different filter for the system when I'm out there, because I don't like some of the results we're getting, and I want to try and get better results. And I might be able to get better results with this new filter, but I'm going to be there to test it. If it doesn't work, I'll take it off. Anyway, so what's funny is this lousy picture, because it has the wind affecting it. If you look here, it's a stack of 107 frames already. So that's way too many. Not way too many, but it's just like not useful, because after a certain period of time, stacked images can't really get much better. There's diminishing returns after a certain number of shots. But we're gonna go back. Go ahead, Daryl.
I'm sorry. How long was each shot?
Only 3 seconds.
Oh, I see. 3 seconds.
Yeah.
Okay.
I'm gonna go back to 1 second here. Yeah, because with the dumbbell nebula, it's so bright that it's overexposed with anything more than that.
Yeah.
So we're gonna go here, do 1 second, and I'm gonna get rid of the stack here. We're gonna say pause the stack, stop stacking pictures, then clear it, and then get rid of the live stacking altogether, and then we'll be back to just doing our 1 second photos. So that's a 1 second photo. All right, if we do the hyper processing little button, and that's my term for it. It's basically like turning the telescope into a glorified finder, if lack of a better term. And that's what happens. See, some shots are good, some shots have wind. But if you look at the telescope, it's like a sail sticking up with the wind coming across the top of the building. All right, and that's a horrible shot right there. I'm amazed we got anything. Hey there, Fantasy. How are you? Good to see you. And DK0018. What's happening, man? Good to see you. Thank you. I'm glad you enjoyed the stream. He was saying it was a good stream last night. It was. Last night and the night before were good. Tonight it's a little windy. I'm going to go check the all sky, make sure we actually have some clear skies here. I'll do an acquisition. Single acquisition. We're doing 12-second exposure. And we'll see, you can see the Milky Way here. And it looks faint, and that's because of the moon. Without the moon, it's just dominates the screen. Okay, here we go. What do we got? Uh-oh. Look at that.
Uh-oh.
Yeah. We're getting clouds. That is no fun, but it makes sense. I saw them coming from Prescott, and I know that there's... And actually, see this right here? You know what that is?
Los Angeles?
No, that's lightning.
Sorry.
That's funny. That's the direction, too. That is west. That's lightning that's showing up here.
Mm.
Yeah. And so, I hate to say it, but I suspect that our night is going to get cut short, guys. Because these clouds are encroaching. See, it's a good thing. That's why this all sky cam is here. It makes sure that we do not hurt anything. Hey, Chantel, how are you? You just arrived, and we may just have to shut down because of these clouds that are here and lightning out there. So, that's still a good 25 miles away. So we do have time, but I don't think that we're gonna have a good night now, unfortunately.
You might move on to the north. You got a bigger pocket there.
Yeah, maybe. I mean, when we look at this,
for now,
this is this is where we're going.
Yeah.
Yeah. Let's try it. We can see. I just don't want to have anything, I err on the side of caution because I'm 2,500 miles away from this building. I can't just go out and say, let's close this now. So let's in my typical, oh look, we got a satellite zooming through. You see that? Very quickly went through. That's the other thing too. We have all kinds of anomalies that come through here too. They're usually satellites, but it's not always. Sometimes there's other weird things like strange aircraft actually have come through here that we've seen. Very, very interesting stuff. Let's while we're here, what the heck? We're so close. We're so close. Let's just go and check this out before we close up. It probably will be very badly ripped away from us by the wind, but we'll do our best. Okay, it's gonna go to this star in Cygnus. But this is Cygnus the Swan, by the way, and to see what I was talking about, if we add in the mythology, the head of the swan down here, this is Alberio, that star I was telling you about. Okay, this is Satyr, which is a star in the center of the swan's body, and then Deneb forms the tail feathers of the swan. And that's a beautiful location as well. So, telescope is centering on that star, and then off we go, and we're going to this beautiful fuzzy object. And what is that? It is the eastern side of a supernova that occurred up in that swan, and occurred about 8,000 years ago. And it's about, oh, look, a cloud coming. Look at this. See this cloud? Look at this cloud passing us right there. Thank you for spoiling our fun. Yeah. Okay.
Bummer.
I know. You said we could do this. No, I know. Yeah, so it looks like we're not gonna get much of a chance here to do this. All right.
Well, that's moving fast.
Well, yeah, it is. So here's what we're gonna do. I am going to park the scope because I am not going to take the risk of anything happening. Actually, before I park the scope, I want to shut down the planetarium system as well. I'm going to go in reverse order because that's always best to do. Sorry, folks, but I'm glad you could join me for the time we had. I was hoping we'd have more time than that, but it does happen sometimes, We did 2 nights, and the third night, it just didn't work out with the wind. So we're going to make sure that we come back. If tomorrow is clear, well, we'll come back tomorrow. Alright, that's down. Gotta get rid of the focus system. Let's see what the temperature is in the building right now. And I'm sorry about the time delay. It's literally a full second delay. Okay, it's 65 out in the building now, so temperature's dropping. Alright, and we're gonna disconnect now. Focus system. And I'm going to now I'll leave this up. Alright, I'll leave this up, but I'm going to park the telescope now, and you'll see the telescope go down to its park position. So, and that's a safe zone for the telescope. Alright.
Well, best laid plans and all that.
Well, you know what? It's okay. I'm alright with that, because I know that we actually did get to see a few things. What's interesting is the telescope is staring pretty much at the building, but the edge of the top is actually capturing some of the stars. You see that? Okay. You'll also notice something else. If I put the pointer here, you can see how the stars are moving slowly. You know what that is? That's the rotation of the Earth. We're rotating out from under the stars. And that's what we're seeing right there. Kind of cool, huh? And now what I'll do, I'll come over here. I'm going to show you the whole shutdown process after all. And now what we'll do is I'm going to shut off the telescope. I use a simple numbering system, which is very simple. And the telescope, after I do this, you'll see turn off pier power. The pier is now off, telescope is off. But the camera's still running because the camera still has power. Because power to the building is still going and power to the camera. When I shut this down, it will all be down. All right.
Question?
Yes, sir?
Is the All Sky still working at this point?
Oh, yeah. The All Sky is still up. We can show. I got to do an acquisition again. It's not. It's a timed exposure. But while we're waiting, I'm going to shut the roof, okay? But
Okay.
first, I'm going to close this guy. All right. And then I can close this. I'm sorry that this happened tonight. This was a fun night. Okay. And now let's do another acquisition. And I think you'll see that we're going to have clouds all the way in here now. These are moving rapidly, so it's probably best that we did close. Okay. Yeah. And notice over here the lightning is not there. That was lightning, as I said.
Yeah.
Okay, at least we don't have precipitation. There's no rain right now, and that's fine. So we're going to minimize this guy. Pier is off, and the only thing left to do now is to close the roof. Actually, that's not true. I can disconnect the scope right now. And I'll disconnect the scope. DK, thank you so much. That's very kind of you. But you know what? I didn't give you $10 worth at all, man. You know, I feel bad. Alright, we're going to close this now. And Raymond, thank you. I missed that, Raymond. I'm sorry. And I'm going to close this now. And now we're back to this. Now we just have to shut the roof. But I'll show you how this works. This is kind of cool, actually. I'll maximize it for you to see it. So there's the view looking in at the telescope. You can see the camera right there on the end of the telescope now. You can see the mirror kind of in the back through the glass plate at the front. Got two spider webs here that Marianne had noticed earlier. Okay, and now let's see. Let's just bring up this guy, which is this guy right here. This is my interface to the program I wrote. And let's just close the lid on this bad boy. Okay. And there we are. We're putting away the scope for tonight. I tell you, it's just unfortunate. But you know what? It's okay. Better safe than sorry, right? Better safe than sorry. I did have the telescope open one night, and I lost what's called an IP connection to the entire computer out there, and it didn't come back until the following morning. Luckily, with the telescope pointing straight up and the roof open, luckily, I always make sure that the night is going to be clear. This night, I'm getting a little bit, I guess you might call it brave, maybe crazy, but I wanted to give it a shot to see if we could do this because it was such a nice night. But it's alright. It might clear up by morning, but I'm not going to be awake for that, I don't think. But this will be good. And this is my control program, by the way, that I wrote for the microcontrollers that I use. I use relays and so forth. It looks complex, but it really isn't. It's actually very simple and straightforward. And I was talking to Daryl earlier. You know how the camera has a rectangular field of view, and sometimes it'd be nice to rotate that camera vertical or at an angle so that you can capture objects that are extended. And I'm thinking of setting up a machine system where I can actually, where this camera is here, this camera would come out and I would put this thing in there called a rotator. And I have a motor that can actually do the turning. But I have to keep it within the diameter of the camera. It has to be smaller than all that. Because I can't go, and I can probably go a little bigger, but I can't go much bigger because of the fact that the view would then be obstructed, and I'm not going to obstruct the view into the telescope. So,
I suppose the most you would need to ever rotate it would be 90 degrees, 40 to 45 degrees.
Yeah, 90 actually, because you might want to go. You might want to go right to the other end of that extreme. But I only have to go 90, and I took apart another device I have in the shop. I have a visual effects business, and that's what astronomers do, I think, right? I don't know. And the business I have stepper motors, and I'm going to use one of those stepper motors to do that. Hey, Tim F. Yeah, I'm sorry that we're closing up, Tim, because of the clouds. This is what we've got looking at us right now. I'll show you real quick. That's what we got looking at us right now. We had it open for a while, but these clouds really encroached on us. Darn you. So, that said, that's unfortunate. But you know, we're gonna have to just deal with it. And I think, in DK, yes, those are spider webs that are sitting in front of the camera. They might be black widows, actually. I gotta be careful because I opened up a closet out there on the site. Then it was full of black widows. There kind of like 6 of them in there.
Boy, the wind must really be getting inside the observatory the way they're still moving around.
I think, first of all, let me show you what you're looking at. These things here, these are black bristle brushes that Tara, who's here in the chat, put up all the way around the building, but there's gaps where the opener is here, and the corners are pretty well sealed, and there's no gaps anywhere else. The door is actually even pretty well sealed up. No critters can get in. But the gaps around here are probably all it needs to get some wind in here.
Yeah.
Yeah. So that those bristle brushes actually help keep the wind out and the sand and grit. I noticed that they get loaded up on the outside of the building pretty good. And there are sandstorms out there, by the way. They're called haboobs, and we have to be careful when that happens. I actually have, you can't see it in this shot, but down here, just off the view, I have a big round cover attached to a big stepper motor. And that is meant to close and open the telescope. And that goes over the face of this cap. I need to add another little stand and to put that on there, because I actually had it attached to the mount of the telescope, and it would close the telescope every night when we were done. But when I added this Hyperstar system, that sticks out like 14 inches from the front of the telescope, and then that dew shield comes out another 6 or so. So we're talking about another 15 inches sticking out of the front of the telescope, even more than that. So I have to make something off the telescope that closes the lid when we go to our park position. But that's alright. That's okay. For now, the dew shield will keep most of the stuff out anyway. And horizontal is the best position as opposed to aiming downward, because when it's downward, if there's any turbulent eddies, they can blow stuff up into the thing. So horizontal is best. But anyway, so there we go. So Daryl, you're not going to have to worry about sticking around till you're dead tired anymore. Not tonight. You know?
We quit at 1 a.m. for me 2 nights ago, and we quit at midnight my time last night, and that 1 hour made quite a bit of difference. I got to bed an hour earlier, and
that's good.
Still slept till 7 this morning.
That's really good. You know, while we're here, I mean, I don't know if it matters, but maybe what I can do is show you guys some of the things we've taken pictures of while we're here. You guys are sitting here being very encouraging and so forth, so maybe I can do that. Let's just take this screen. Okay, I want to do this.
Mark, if you'll excuse me, I'm going to call it a night, okay?
All right, Daryl.
Alrighty. Thanks for trying tonight, and good night, everybody. Thanks for coming.
We tried. All right, Daryl.
Alrighty.
Talk to you.
You take care.
Talk to you again.
Bye-bye.
Bye. So, last night's picture that we took, this was the Sol Nebula. Okay, that's the one that we took last night. That's a 25-second photo and stacked. Isn't that pretty? So that was last night's shot. These are dark nebula in here and hydrogen gas that's actually being ionized by hot young stars, such as this cluster here. This cluster is part of the driving force of this nebula, and it's amazing to think that something this far out can be influenced by starlight, but it's an illusion because it's a 3D universe. So these things are really, it's a straight beeline to that, you know, and a straight beeline to all these other areas. And sometimes something that looks close is not and won't be lit up, but it's the weirdest thing, you know. So that was one of the things we looked at last night. I want to show you one more, and then I'll let you guys go. This region here, oh, I only have it in a PSD, but that's okay, it'll still. Okay, this was a beautiful nebula that is near the center of the swan, the body of the swan, that star Satyr that I told you about. That is this nebula right here, but there's a lot more to it. There's a lot more down. This is just the northern piece of it. But what's neat is there's 3 little reflection nebulas in here. Look at that. These are nebulae where there's dust that's being illuminated by bright stars, hot stars, but not enough gas to actually glow and cause the red that we see here. Pretty cool, you know. So those were 2 of the primary things we did last night. And so this is our entire directory. Most of these things you can find out on the directory in our online server. So do give that a look-see, will you? So that said, I'm hoping that maybe we can do this again very soon. And yes, a lot of hydrogen. So sorry for the short night, guys, but I hope that you'll join me again next time. So thank you, and I guess I'll see you on the other side of this. Good night, everybody.